Hi everyone, my name is Mtagura Jonathan, a software engineering student at Bugema University. I participated in the Google Summer of Code with OpenMRS, working on replacing OpenMRS Standalone with a modern user-friendly alternative. And in this video, I'll take you through my journey during my internship, the challenges I faced, the solutions I implemented, the skills I gained, and the impact of my work on the OpenMRS community. OpenMRS is an open source platform that powers healthcare systems worldwide, and the standalone application allows users to run OpenMRS locally without complex server setup, whereby you need to just double click and it's able to run the OpenMRS. However, with the older OpenMRS standalone system, we had a lot of limitations. It majorly relied on outdated dependencies like the MXJ. It lacked support for Apple Silicons. Those are the M1 and M2 chips. And it couldn't run beyond versions platform 2.5 and reference application 2.12. This caused challenges for developers and limited adoptions of newer OpenMRS features. And the following were my objectives during my GSoC internship. One was to replace the legacy standalone with a modern double-click runnable distribution that is simple for non-technical and users to install and run. I had to also ensure cross-platform compatibility, including support for Apple's M1, M2 silicon chips, and to adopt the Java 17 and beyond. I had to also use a dependency which is embedded, which comes with the MariaDB embedded system, and that is the database engine which the standalone is to run on. Also, I had to support OpenMRS Core 2.7 and beyond. And provide a standalone distribution for 2.x, 3.x, and Core Platform 2.7 and beyond. Also, another objective was to automate builds with CI pipelines to generate and publish artifacts for each supported distribution. The following is the design for the OpenMRS standalone system, whereby when you download, you will need to download a zipped file and ensure that you have Java installed on your machine. After that, unzip the file and you will see OpenMRS jar file inside, which for Mac users you will be able to use the terminal to run it or double click it, together with the Linux and Windows users. And also for the Windows users, you can double click it. A window display whereby it will ask you whether you need a demo data or you need the empty database. OpenMRS to start on an empty database. Over the 12 weeks, I've made significant contributions to OpenMRS standalone, whereby I've been able to achieve OpenMRS standalone to be able to work with the platform version 2.7 and beyond. I've also made ref app 3.x to also work properly on standalone, and also 2.x also now functioning on the platform. I also added Windows compatibility and improved 3.x standalone in order to run the demo and the empty database as required. I also resolved the snapshot artifact resolution issues. I upgraded the 3.x to work with 2.8 and also fixed the reserved keyword which was showing in the database logs. The following is the video on how OpenMRS can be started using the standalone system. During my internship, I faced several challenges, and one of them was with Windows, the MariaDB would fail on non-empty data directives, and this required me to use to implement a custom class that would resolve this issue so that it's able to accommodate Windows. I also faced a challenge of Maven snapshot resolution, whereby some 3.x snapshots could not be loaded or resolved in the OpenMRS during the build system. And with the guide of my mentors and OpenMRS community, I adopted a two-step Geno distro and build distro step approach, which would fetch and build the system. There were also database initialization delays by using Docker, I copied the pre-installed checksums folders to install to significantly reduce the first run initialization time. I also had a long problem of SQL result error, and through my mentors and my guides and the OpenMRS community, I was able to simply resolve it. The following are some of the lessons I learned and the skills I gained. In the technical skills, I was able to advance my Java skills, my Spring skills, MariaDB and OpenMRS core, and also my debugging skills. And in the non-technical skills, I was able to learn that time management is really important, and collaboration skills are really necessary because they enabled me to communicate with my mentors and learn a lot on how we can all work together to accomplish a common goal. And in conclusion, my special thanks goes to my mentors, Daniel Kaiwa, who was my primary mentor, Wickham, who was my secondary mentor, Ruhanga Nathan, Mohereza Haman, and the OpenMRS community at large. Thank you all.